1 here. So we're going to look at 3, 1. And we're going to begin now with question number 1. And question number 1 is a matter of, is this ordered pair a solution to this equation? Now, how do I know if something's a solution? A solution is when I plug the ordered pairs in if the sides match up. So my question is 1, and my equation is y equals minus 2x, and we're going to check 1 comma negative 2. Now, the x always goes first, y is second. So when I plug these in, let's see what happens. Okay, and if the sides match up, then I know I did it correctly, and it's a solution. If I plug that in, y is a negative 2. Right? And then we've got negative 2 times 1 for the x. So negative 2 equals negative 2. So these are the same. So therefore, this is a solution. Right? So if the sides match up, then it is a solution. And that's all you need to do for question 1. Question 2, we need to complete the missing part. So complete the missing part of this ordered pair. So for question 2, well, we've got 4x plus y equals a negative 29, and we've got a partly completed ordered pair. So we've got blank comma negative 29. Now, when we plug this value in, we need to figure out where the 29 goes. Well, the 29, that is associated with the y component, isn't it? Right? Because it always goes x first, y is second. So we're going to be plugging in the value for y, and then that's going to give us our x value that goes with it. So let's plug in our y value. So 4x stays the same. Y is a negative 29. And that equals a negative 29, right? Okay, now, we've done a lot of these where we solve them. We add that 29 over. And that gives you 4x equals now what? 4x equals 0, doesn't it? And when we divide by 4, 0 can absorb that 4. So x equals now what? X equals 0. So what would the answer that I want to see here be? 0 for that missing component. Do we see how it works? We just plug the value in, we get the other value. Question 5, we need to complete this table. Right? So question 5, we're going to try to complete the table. And when we look at the table, we've got lots of missing parts. It looks like the only part we're missing, though, is the x's. Right? So all these given are the y values. And we need to find the corresponding x values. And then we need to graph it. Okay, so we need to find all the missing x values. So what do we do then? Then we just plug the y value in for each one, right, of each one. We find the x value that goes along with that specific y value. Then we make our ordered pairs. So we need to fill in all these blanks. So the first one, we're going to plug in y equals 0. And if I plug in y equals 0, well, that's easy because that's x minus 0 equals 1. So that gives me then x equals what now? X equals 1. So there's that part right there. Okay. Now we do the next one. And the next one, we're going to plug in what? We're going to plug in 2. And that is getting plugged in again for what? The y value, right? So let's plug in now y equals 2. And be careful with your signs. So that is x minus 2 equals 1. And we can finish this by adding our 2 to each side. And so x now equals what? looks like x equals 3, doesn't it? Okay, so there's the next piece. And the next one is going to give us a double negative, because the next one we're going to plug in a negative 2. Well, when we plug in a negative 2, that gives you a negative of a negative, right? So it's going to be a positive value. So let's plug that in and see what we get. So we get x minus. Now, when we plug in a negative, we always have to put parentheses around it, don't we? That way we know that the double negative here is going to make this now what? Positive. So that gives us x plus 2 equals 1. And we'll move that 2 over. So now we've got our next part, which is negative 1. Okay, are we all right with that so far? And let's do the very last one, and then we'll graph this. So our last one is 4. And so we're going to plug in the y equals 4. And so that's x minus 4 equals 1. We're going to add that 4 over. And so now we get x equals what? X is going to equal here 5, won't it? Because 1 plus 4 gives you the 5. So is everyone okay with how I did that? Now, we also want to graph it. So if I want to graph this, I'm going to plot those ordered pairs, and then I'm going to connect them together with a line. They should be able to be connected together with a line. So what do my ordered pairs look like? Okay, let's write them out. My ordered pairs are 1, 0, 3, 2, minus 1, minus 2, and 5, 4, right? So those are our ordered pairs. Now, when we connect them together, this should make a straight line. If it does not make a straight line, then we know we made a mistake. So if we plot these and they don't connect together to make a straight line, we made a mistake, and we're going to have to go back and rework them. Let's go ahead and plot our ordered pairs now. Remember, this is your x, this is your negative x, this is your y, and this is your negative y. So let's plot our ordered pairs, and we're going to start with 1, 0. So 1, 0, remember, x goes first. So that tells me then we're going to go over 1 unit. And are we going up any? No. So 1, 0 would be right here. All right, so there's that dot. The next dot is at 3, 2. So what is that? That's over 3 and up 2. So right there is 3, 2. And the next one is minus 1. So that's back 1 unit and down 2 units. So that's right there. And then finally, the very last one is over 5. So there's 3, 4, 5, and up 4. So 1, 2, 3, 4. And now when we connect these together, you should be able to connect them together with a straight line, which we will be able to, right? Pretty much. I mean, that one's off a little bit down here. But you've got graph paper, so it'll be a little bit easier. But you should be able to connect them together. And there is your line. Okay. So we plotted our points. We connected them together with a ruler or a straight edge. And then that gave us our graph there. Is everyone okay with how to do that? Now, the key takeaway is to remember, x always goes first, y is second. And that's where students tend to make a mistake. The students tend to look at things, and they make a mistake because they get the x and the y mixed up. Question 6 is this. Okay. Yep, x is always first, right? Ordered pairs go like this. This is called an ordered pair. And ordered pairs go x, y. So the x always goes first, the y goes second. So like when I plot 1, 0, I would go over 1, and then it wouldn't go up any. 3, 2 would be over 3, and then up 2 units. 5, 4 would be over 5, right, and then up 4. Question 6. Question 6 is x minus 2 equals 0, and we're going to have to complete this table. Now, what do we notice that's different about this one versus the last one? Right, it has no y value. All it has is an x value. And it's not been solved for x. So if we only have one variable, we need to make sure that we solve it for that one variable. So right now we've got x minus 2 equals 0. So we're going to add the 2 over so that we get the x, the only variable, by itself. And now we've got x equals 2. Okay? Now, what does that actually mean? Let's think about what that means. If I say x equals 2, y is not even a part of it, is it? There's no y in here at all. So what it says and what it means is y can be whatever it wants to be, but x always, no matter what, is going to be what? 2. Y could be 1,000,000, and what is x going to be? 2, because x is stuck at what value? 2. That's what it is. It says x equals 2. That's it. So all these x values are all going to be now what? 2. Yep. And if they just have one value or the other, remember, if it's just an x line, if it's an x only, it's going to be horizontal. Okay? And we'll talk some more about that here in a moment as well when we get to the later sections. If it's a y only line, it's vertical. If it's an x only line, it's vertical. And if it's a y only line, it's horizontal. And if it's got both, then it's diagonal. So this one is an x only line, so it's going to be vertical. And what do our ordered pairs look like? Well, they're at 2, 0, 2, 2, okay, 2, negative 2, and 2, 4. And so if I plot all of these, it's still going to make a line, right? But it's going to be a vertical line, up and down line. So let's plot them. If we're at 2, 0, that's going to be over 2 and at 0. The next one is at 2, 2, so that's over 2 and up 2. And the next one is over 2 and down 2, right? And the last one is over 2 and then up 4. And look at what happens if I connect them together. Well, they still make a line, don't they? It's just that this line is not a diagonal line. This line is what? This line is vertical. And here's how I remember that x lines are vertical lines. When I look at this, what axis does it cross? It crosses the x-axis, right? So if it crosses the x-axis, the only thing it can do is go up and down like this. So it's a vertical line. So whenever it's an x-only line, it's vertical. If it's a y-only line, it's a horizontal. And if it's got both, it's going to be a diagonal. So does that clear up that one a little bit? But if there's only one variable, what you have to do is you have to solve for that variable by itself. So it needs to be by itself. Question 8. Now, question 8 is just like what we've done before, but instead of it being aligned vertically, it's aligned horizontally. So it's going to make no difference. And I'm not going to work this one completely out. because I'm going to leave the last one for you to finish. So you're going to have to fill in that last box there, but I'm going to do the other two. So we don't have to graph this one. All we have to do is complete it. And in this case, we've got the x values. So we're missing the y components. So what do? We plug in the x value, we find the y. Plug in the x value, find the y. And I'm going to leave the last one for you to do on your own, because I'll do the first two, and you can do the last one. So the first one we're going to plug in is x equals a negative 3. So that's 4 times a negative 3 plus y equals negative 3. And 4 times a negative 3, well, that's a negative 12. And remember, we want to get the y by itself. So what do I need to do with the 12? Okay, I need to move it over. And so what am I going to have to do? It's negative. So what's the opposite of that addition? Oh, sorry. The opposite of this negative subtraction is what? Addition. So we're going to add 12 to each side. And so the first blank is going to be y equals now 9. So that goes in our first one. So there's that. And what about the next one? Well, for the next one, what are we going to plug in? We're going to plug in 0. So let's plug in this 0. And that's 4 times 0 plus y equals negative 3. Now, what happens when we have 4 times 0? That's 0, right? And what happens when you take 0 and you add it to y? Does it change it at all? No. So 4 times 0 is 0, and that piece is gone. So that leaves me then with y equals now what? Negative 3. And you should now be able to finish the last blank, because we've done several of these. And you can finish that last one. Question 12. We asked about 12 and 13. I'm going to do 12 because 12 and 13 are almost exactly the same. It's just different numbers. So I'm going to do 12, and you can do 13 on your own. They're almost exactly the same. They just have different numbers that you're plugging in. So for question 12, they give you this. They give you this equation. And just like we've done numerous times before, we need to fill in the missing blank. And you'll notice that 12 and 13 are almost exactly what? The same, aren't they? Right? So I think if I do one, then you should be able to do the other one. They're exactly the same. There's not really any difference at all. We've done a lot of these. Ordered pairs always go x, y, don't they? So this negative 5, well, that's going to go in for the x value. So we'll plug in that x value and be very careful with the double negatives here. So use parentheses whenever you plug in a negative value. And don't forget your equal sign here. And what do we know about negative 4 times negative 5? Positive 20, right? And then 20 minus 18 leaves you then with y equals what now? 2. So that's going to go right here. They're starting to make a little more sense now. We just plug in our values. And fill in the missing part of the ordered pair. And that's basically what all they are. All these are pretty much the same. You just plug in the values. Okay, check to see if it's a solution on some of them, if they give you both parts. Otherwise, you complete the table. And if you graph it, well, that means we just plot those points, and then we connect them together. 3.2, we had some questions as well. And we're going to look at the first one. And 3.2 is really not much different than 3.1. They're pretty much exactly the same as what we've already done. We need to graph this. So we've got 4x minus y equals a minus 4. And we've got ordered pairs. And we're going to have to complete these ordered pairs. Now, I'm only going to do the first two. You can finish out that third one. To graph a line, you really only need 2 points because you can use a ruler with just 2 points, right? You can do 3, but you really don't need 3. You can get by with just 2. So I'm going to do the first 2. I'm going to graph it, and then you're going to have to do the last one here. So let's go ahead now and plug in x equals 0. All right, and so we're going to fill this in. And we know that 4 times 0 is 0, so that's gone. So now we have minus y equals a minus 4. Is minus 4 going to be our answer, though? No, why not? Because we don't solve for negative y, we want what? Positive y. So how do I get my actual answer? I divide by a negative 1, don't I? Don't forget that step. And now what do we have? We now have y equals what? 4. So there's that piece. Now let's plug in the next part. The next part is y. And that's y equals 0. So that's going in. And if I plug in y equals 0, well then that is 4x minus 0 equals a minus 4. Right? 0 doesn't matter. And so we have 4x equals a negative 4. And how do we finish this out now? Okay, divide by a positive 4. And so my answer is x equals a negative 1. So that goes up here. Now, you're going to have to finish this piece. I'm going to let you finish it. I can graph it because I can graph this with just 2 points. Right? All you really need is the 2 points. So let's quickly just graph it so you know what it's going to look like. Now, we have an x and a y, so that tells me that my line should be a diagonal. Okay? You're still going to have to fill this one in, but we can graph it with just these 2 because you only need 2 points. So let's graph it, and you can finish that one on your own. 0, 4, there's your x, there's your y. 0, 4, it's not here, right? 0, 4 would be where? Up here. So 1, 2, 3, 4, and right there is 0, 4. What about the next one? The next one is negative 1, 0. So that is back 1 unit. So there's negative 1, 0 right there. And when I connect them together, it should make a diagonal line. And there's your diagonal line. Now, you find that last point, and it's going to be on this line. But I don't want to work it all out because I want to leave something for you to do. But I did 3/4 of this question, and you can do the last part. question 4. And question 4, we're going to graph this line. Now, does this one give us any ordered pairs to work with at all? No, but we can make our own ordered pairs up. So for question 4, we're going to find what are called the intercepts. And for the intercepts, we plug in our zeros. So we've got an x-intercept, which will be this one, where it crosses the x-axis. And we've got a y-intercept where it crosses the y-axis. So it'll be this one. And how do I get those? I split them up, and each one's got the 0. Now you're going to get 2 points because they're different. And those 2 points, we can plot them, and we can connect them together to graph our line. So our first one, this is your y here. So we're going to plug in y equals 0. So that's 0 equals x plus 1. And we'll move that negative 1 over. And so now we have one of the ordered pairs, which is at negative 1, 0. And that is going to be your x-intercept because that's where it's crossing the x-axis. The next one we're going to plug in x equals 0. And if I plug in x equals 0, well, that's y equals 0 plus 1, which is just simply y equals then what? 1. So that's that piece. Now, do I have 2 different points? Yes. As long as they are different points, then you just plot them and connect them together. So we've got minus 1, 0. That's back 1 at 0. And the next one is at 0, 1. So that's at 0 and up 1 unit. We can now connect these together. And these will make a straight line. And that's all you need to do on question 4. And all of these are very, very similar. We know it's a diagonal line. Why? Because it has both the x and it has the y part. If it has both, then it's diagonal. If it's an x only, then it is vertical. If it's a y only, it's horizontal. This one had the x and the y both, so that told me that it had to be diagonal. Question 5 is probably going to be very similar. Let's flip the page here and see. Question 5 is very, very similar. I'll do 5, and you can do 6, because they're very, very similar to each other. Okay, 9x plus y equals 0. Now, we want to graph this, and do they give us any points? No, they do not. No points are given. So we're going to make up our own. What do we use? We use the 0. So if they don't give you points, you can use the 0. And that gives you the 2 of them. Let's plug them in and see what we get. So this is your y here. So we're going to plug in, first off, y equals 0. So now that's 9x plus 0 equals 0. 0 doesn't do anything. So 9x equals 0. Divide by our 9. So what do we know about x again? X must also be what? 0. Let's do another one. Let's plug in the x equals 0. Well, if I plug in the x equals 0, it's going to give us the same thing. Does everyone see why? Because 9 times 0 is what? 0. So that gives you the same 0. But that's causing us a problem. Why? I have to have two different points to connect a line. Right now, I only have one. So how do I get another point? Well, we pick a value that we want to use for x, and we find the corresponding y value. So just pick any value that you want for x, and I always like to pick 1 because it's usually pretty easy to work with. So I'm going to add on another ordered pair. Why am I doing that? Because we only have 1. We need to make sure we have 2 different points. So I'm going to plug in 1 for the x. And you can use any number that you want, but you want to pick an easy number. Right? You don't want to pick 10 or 5. Pick the smallest number possible, which is like maybe 1 or -1. That way it's easy. So I plugged in my x equals 1. And so that's 9 times 1 plus y equals 0. And 9 times 1 is 9 plus y equals 0. And then now we just move our 9 over. And now we've got y equals a -9. Right? And that's another ordered pair, isn't it? So now we have 2 distinct ordered pairs. They have to be different. So we've got 2 different ordered pairs. They have to be different. If they're not different, you have to add on another one. Now I think for question 6, okay, they're going to be different ordered pairs. So it's not going to have the same level of difficulty as this. You're not going to have to add an extra point on. 7 is like this one. 7 and 5 are very similar. All right, 6 is going to give you 2 different points. 6 is kind of like 4, the previous question. So, what do I need to now do? Plot my points. And what do we have? 0, 0, which, by the way, 0, 0 is called the origin. So if you see the origin, that means 0, 0. And my next point is at 1, -9. So that is over 1 unit and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that puts my second dot right about there. And now what do we know? We've got 2 different points. So that's all we really need to connect these together. And there is my line. Right, so that's what your graph is going to look like. Is everyone okay with that? And you should be able to do question 6, because it's the same as 5. You don't even have to get the second point. It's like 4. 10 and 14 are the last 2 from this section. And question 10 is just like what we've already done. We just did this. We didn't call them the intercepts, but that's what we just found. So question 10, we just want to find the intercepts. Now, when we talk about the intercepts, they're ordered pairs, okay, and they have the zeros. Now, which one is which? How I remember them is this one is the x-intercept because the x is going to be a number. Right? When we find it, you have to find the x, and that's going to be some number, comma 0. That's going to be your x-intercept because you're missing the x part. This one, we're missing the y part. So that's going to be your y-intercept. So we have 2 intercepts, an x-intercept and a y-intercept. Now, we just did this in the last question. It was just talked about in a different way. Okay, we use it to graph. Now we're just finding the intercepts for the graph of the equation. So All they want you to do is find these intercepts. You don't have to graph it. They just want you to calculate the numbers out. Okay, there's no space to graph it. All we have to do is find the two of them, and they're labeled, the x-intercept and the y-intercept. So for the x-intercept, we plug in y equals 0. And so that's that. Now, what do we know about 2 times 0? 2 times 0 is 0. So that's gone, isn't it? So minus 2x equals 10. Divide by our negative 2. And so now that gives me x equals a negative 5, isn't it? So there's that piece. That would be your x-intercept, right? You don't put them together. They are separate numbers out. An x-intercept and a y-intercept. They are separate. Do not put them together. What about for the y-intercept? Well, we plug in x equals 0. And that's minus 2 times 0. Minus 2y equals 10. Well, minus 2 times 0 is 0, and that is gone again. So minus 2y equals 10. We'll divide by our negative 2. And so y now equals negative 5. So there is the y-intercept. Now, do not put them together. I see this happen a lot in this course, in intermediate, and in college algebra. A student's going to come along, and they're going to say, this is my answer. Right? You cannot put them together like that. They have to be split out like this. So do not try to put them together like that. They are different ordered pairs. Split them out. Do not do this. But I see that happen in this course, in intermediate, and even sometimes in college algebra. They'll try to put them together like that. And they are two different ordered pairs. And we've got one more question to look at out of 3-2, which is question 14. And the only hard part about 14 is 14 has that fraction in there. And again, they just want you to graph them. 3-1 and 3-2 are very, very similar to each other. 3-2 is more or less kind of a review of 3-1. It's just reinforcing the same concepts again with a little bit more graphing. What I'm going to do is I'm going to work out two of these, and I'll leave one of them for you to do. Now, I'm going to work out the fraction one because I figure that's where we probably have the most trouble. So I'm going to do the first one and the fraction. And I will leave the middle one for you to do. So I'm going to do the first one and the last one. And you're going to have to complete the middle, because I don't want to work it all out for you. I want to at least have something for you to go back and review. But I know we probably struggled with the fraction, so that's why I'll do the fraction. So let's work with our first one. And the first one we're going to plug in. Remember, x is missing, so we're going to have to plug in y equals 0. And if I plug in y equals 0, well, that gives you x equals 3 times 0 minus 5. And 3 times 0 is 0. So that leaves me then with x equals a negative 5, doesn't it? There's that. Is everyone okay with that? Because you plugged in y equals 0, and that just went away. This one, you're going to have to finish out. I don't want to do it all for you. What about the last one? What goes in? 1/3. And that's going to go in for the y value. Now let's remember a little bit about fractions and how they work. When I go to multiply, what can I do with these 3's? What's 3 times 1/3? 3 times 1/3, those 3's can do what? They can cancel, can't they? So that would then leave you with x equals, those cancel, and what's on top? 1, and 1 minus 5 makes it a -4. So you're going to have to finish out the middle one. Now we also need to graph this. And how do we graph a fraction? Well, when we go to graph a fraction, we just kind of plot it to where we think it is, or pretty close to it. It's not going to be exact. We're just going to kind of get a rough idea. Now, all we need is 2 points, so I can actually graph this without having the third one. But you're going to have to go back and finish out that third one. To get full credit, I need to make sure you have that one filled in. So that just leaves you a little part for you to work with. Now, what are my 2 ordered pairs? Well, -5, 0. Remember, x always goes first, doesn't it? So it's not going to be down here, is it? No. Where's it going to be at? Back over here. So, -5, 0 would be back 5 units. It's not down here, it's over here. Make sure you're very careful with that. That's where students make mistakes at, is they put it down here, but it's not, because this, remember, is your x value. And x always goes left and right, and always goes first. What about the next one? All right, the next one is at -4, so that's here, and about 1/3. So -4 and up about 1/3 would be approximately there, wouldn't it? It doesn't have to be perfect because, again, we're just doing quick sketches to get an idea, to get a visual idea of what's happening. And all we need is these 2 points. Now, you need to fill in the last one, but it's going to be on this line. To graph a line, you really only need 2 points. You can have 3 or 4 or 5, but you really only have to have, at minimum, 2 points, 2 different points. Let's do some questions out of 3-3, and then we'll take a break, come back, and finish up 3-4, the questions. So there's only 4 questions out of 3-3, and it shouldn't take too long to go through, but we'll do at least 2 of them. Okay, so let's now move on. And let's look now at 3-3. And we're going to begin with 3-3, question 1. So this is what they gave you. Okay, they gave you a line. That looks like this. And they want you to find the slope. Okay, so we're going to be finding the slope here. Now, first off, do you think my slope is going to be a positive number or a negative number? Just looking at that blue line there. Positive or negative? Okay, well, think about it as a roller coaster. What am I doing? From left to right, we're going up. If we go up from left to right, then my answer should be what? Positive. So they gave you a picture so you could see that this is going to be positive. If my answer comes out to be negative, I made a mistake. So for ordered pairs, they gave you 0, 7/2 and -7, 0. So that's what they gave you. Now, we know that our answer has to be positive. And remember that we talked about the slope formula. M, that little m, represents the slope. And our slope formula is y1 minus y2 over x1 minus x2, right? Because that's rise over the run. Now let's plug our values in. There's x1, y1, x2, and y2. So we plug our values in. So that's 7/2. That's your y1 minus 0 over x1, which is 0, minus, now watch your signs here, a minus 7. That's where you may have made a mistake, and if you thought your answer was negative, it was probably the double negative that got you, because we know that the double negative here is going to make this now what? Positive. So let's see what we're left with. We are left with 7/2 over 7. Now, how do we work with division? With fractions, we make that division into multiplication by using the reciprocal. So, we put that 7 down below as a 7 over 1. This is a fraction. This is another fraction. And how do we handle division? Remember, we turn it into multiplication. And so that's going to be 7/2 times, we flip this over, 1 over 7. Okay, remember how you flip the fractions over to divide? Okay, so this fraction stays the same. This 7 over 1 becomes what? 1/7. Now, what's going to happen when we multiply here? The 7s are going to do what? Cancel. And so what am I now left with for my slope? 1/2. Does that make sense with the picture? Yes, because our picture looks like that slope should be what? Positive. And is my answer positive? Yes. Now, if you encounter a fraction over another number, what do? Make that other number below a fraction, and then you have a fraction divided by another fraction. So the first fraction stays the same. The second fraction gets flipped over and becomes multiplication. And then those 7s can just directly cancel. So let's do one more, and then we'll take a short break. And we're now going to look at question 3. And question 3 is very similar to question 1. But we have to come up with our own ordered pairs to find the slope again. Okay, so let's look here at question 3. And we're going to look at it. We're going to talk about it. We're going to read it and see if and see what we're trying to find and see if it is going to make sense. So let me get this focused here. Just try to manually focus this. Sometimes it wants to do this. Just a second here. Let me focus it right. Sometimes it does that when it tries to focus itself on a question with small print. So that's I think fairly clear there. Okay, so data regarding the amount of money spent by the government department is represented in the following graph. And find the slope of the line using any 2 points shown on the line. Is the slope equal to the yearly change in the amount spent? Okay, and yes, it will be. Right now, look at your line here. It's going up, right? And we know that the government always spends more money every year, right? They never decrease the amount of money they spend on services. They always give you more because more people draw Social Security, things like that. So the value is always going up. Now, we need to come up with our ordered pairs And then we'll find our slope, and our slope should be positive because this is going up. When I look at this from left to right, it's going up. And if I think about government spending, what do we know about government spending? Again, it's always going up, right? You're spending more money every year on Social Security. Now, we need to come up with our ordered pairs. This is your X, this is your Y. And this is in terms of billions. So let's try to come up with two ordered pairs. So the first one is your X value, and that's going to be the year. The Y value is the amount. And we need two different points. And we've got plenty to choose from. This one I can't really read that easily, so let's use this one. Okay, this one looks like it's at about 1998, so that's going to be my year from the picture. And what's its value? Okay, well, let's look. That's 7.2, right? That's 7.4, 7.6, 7.8, and there's 8. Because they're going in 0.2 each time. So this is 7.2. That would be about 7.4. So this one's at about 7.1. 7.6. Does everyone see how I read it? And this is a skill that you'll use in your science classes as well, having to read graphs. We need another one. Okay, the next one is 1999 for the year. And what's its Y value? What's its amount? What's its amount? Okay, there's 8. And there's 8.2. There's 8.4. Well, it looks like it's right in between, doesn't it? So I would say it's at about what? It's at about 8.3. And you could have used this point also up here. Doesn't matter. You could use that one just as easily, because that one would have been at 9. Now we know our value is going to be positive. Let's calculate it out. What's my formula for the slope? y1 minus y2 over x1 minus your x2. x1. y1's here. x2. y2's here. Let's fill it in. And that's 7.6 right, minus 8.3 over 1998 minus 1999. Now, we know that my value should be what? When we work this out, we already looked at the picture. And when we looked at the picture and we thought about it, just using common sense too, when you think about it, what's it doing? It's going up. So my slope should be what? Positive. If it's negative, we probably made a mistake. So 7.6 minus that 8.3 in the numerator is a minus 0.7. And what about 1998 minus 1999? Well, that's a negative 1. And we know a negative divided by a negative is a positive. So there's my slope. Now, what does that represent? Okay, let's talk about what that represents. That is 0.7 billion per year. And that is how much it increases. Not the total amount, just how much it increases. So every year, what is happening? Every year, on average, the government spends $700 million more. Not total, just more than last year. Let's go ahead now and take a short break, and then we'll come back. We'll finish up the questions out of 3.3 and 3.4. We'll finish up 3.4 and hopefully get through most, if not all, of 3.5. So we'll meet back here in about 10 minutes, so about 9:10.